we're getting to even more excitement now in this session, where we're trying to talk to some of the data consumers and what are some of the thorny details of using the data that's out there, if it is, and what do you do to get around that gap if it isn't there. So we'll be joined today by both MoveIt as well as IBI Group, who are consuming this data in very different ways. So it's really instructive for us to learn how and what they do to bridge the gaps. From MoveIt, joining us is Uli Galoz. He's Chief Business Development and Strategic Initiatives at MoveIt. He serves in his role, including global strategic partnerships and new business initiatives at MoveIt. He's a serial entrepreneur with over 25 years of senior management in the tech industry in positions of CEO, top business development executive positions, and he joined MoveIt at the end of 2019 after serving as VP of Business Dev and Vimeo through the acquisition of Magisto. So please help me in welcoming Uli Galoz.
Okay, so I'll talk a little bit about accessibility at MoveIt. MoveIt actually was established as a mobility app with the idea to serving everyone or making mobility reachable for everyone. We are about 30%, 25 to 30% of our users are disabled in one way or another, and we know that through their phone settings and through other hints that they give us through their profile. So it's a significant part of our user base, and we're trying whatever we can do to include accessibility into our product. We are an independent subsidiary of Mobileye, which is a subsidiary of Intel. So we are connected together as a mobility solution. We were established about 10 years ago. And 3 years ago, we became part of the Intel mobility family. We have a huge deployment. We have a mobility app. It's a multimodal mobility app that includes all modes of transportation except car. So if you want to go with your car, don't use us. If you want to go anywhere else, we will give you opportunities, or we'll show you the options to get from point A to point B. We have a large deployment, global, 1.5 billion users right now that use us on our iOS, Android, and web platforms. Every day, we have about 250,000 downloads. So it's a massive system that is covering a huge geographical space, basically the whole globe. We are in 3,500 cities all over the world, 112 countries, and as part of our mission to reach everyone, we're supporting 45 languages. So talking about visitors, new immigrants or anything, our system, based on your phone language, you'll get the app will be in that language. So when we talk about accessibility, there are many accessibility issues that we need to solve. Clearly, there are visual, hand motor impairments, and ambulatory. On the visual impairments, it's not only blindness, it's also color blindness, age-related with a long arm effect, and for hand and motor impairments, we're talking about tremors, paralysis, slowness, and for ambulatory, it's both temporary and permanent ambulatory issues. So the question is, how do you solve that? Clearly, with an app or as a service, and it's a huge challenge. I'm sure you know that. So what we're doing in general, we do it with different bodies who are like organizations that help people with disabilities to solve that problem. And they are working with us on defining the needs and also auditing the results. Is it helpful or what's going on there? Again, I don't want to say that we have solved anything because it's an ongoing challenge, that we're constantly and continuously improving on. But we have done a lot of work there, and I'll talk about it right now. So for visually impaired people, the app itself has a voiceover and talkback. This is basically Android and iOS solutions for visually impaired people. How do you use the phone? Basically, they touch areas on the screen, and what they touch speaks to them. Now, if you look at the screen on a Move It app, you can see that there are a lot of icons. You know, there's a walking, 5 minutes, and then a bus, and then another system, another bus, and you see the yellow information tabs for service alerts. So this is clearly, if you speak that, nobody will understand what's going on. So as part of our solution, basically for every such area, we tell a story to the user. So when you put your finger on an area on the screen, this is like an itinerary, it would say, you know, route 1, walk 5 minutes, then take bus, Eged 277. It actually will talk with you the full context in full sentences and not just spit out the information that is on there. So that's an approach of using, you know, upgrading the generic voiceover and talkback into an actual usable solution. We worked with the Joint is an Israeli nonprofit organization. They actually are working with elderlies and people with disabilities. And we had a project with them where we created special profiles that, for instance, somebody can say, I'm a slow walker. So even if you're a walker, you can say, I'm a slow walker. So the app actually does journey planning. So when it does the journey plan, it takes into account connection times. And if there is a walk that usually would take 4 minutes, they would say, OK, I'm not going to give this itinerary if the person is going to, it's going to take them 10 minutes. So we're trying to accommodate for those based on information that we have. Another one is how much time do I have there? I think it's here, yeah. Then how much time do I have, or what is the maximum walking distance or time that I'm willing to take? I'm willing to take 3 minutes walk. If it's more than 3 minutes, don't give it to me. I mean, and those kind of things basically help us prioritize routes that would be more usable to people with disabilities. Another one is accessible routes. This is a very tricky issue, as we discussed before. Accessibility is not an easy information. We don't have a lot of information there, but we do whatever we can. The accessibility is both in the, you know, there is a vehicle accessibility, there is a stop accessibility, and of course, there's a connection accessibility. So on the connection accessibility, I think we basically don't have information today. This is like the sidewalk project could be a source for there. Again, you know, we need large deployments, not single points. But so the sidewalk project could be a solution. But for stops and for vehicles, it is part of the GTFS. The problem is that it's not really supported well. And we'll discuss it a little bit further. Specifically, we also work with agencies to provide specific solutions for in the way they solve their problems. So for instance, the Israeli train system is, they have an in-station staff who would help people with disabilities to get in and out of the train. So in order to do that, you need to basically let them know that you need that help. So we've added a button in the app that if you take the train, specifically on that segment, you'll have this button. If you need help, you click on this button, and a person would show up and help you move from one place to another. Another agency in Israel called Eged, it's the biggest transit agency. It's a bus-based agency. They actually created a white label Move It app, where actually it's connected to the driver. So a driver receives a message when a user says, I need help. or if people with disability needs help, the driver is getting notified before they reach the station. When they reach the station, they actually go and help. They know that they need to stay, to stop, look for this person, and help them get on the bus. This is how it looks on the bus. So the driver has a like tablet here that tells him what's going on, when the user actually clicks a button and says, I'm there. So what you saw are just different ways of us handling accessibility. Just about visual impairment, there are more things that we need to take into account. So there is type. We accommodate for type. So if you need bigger font, if you need bigger font, you can actually select bigger font, and we will adjust the screen to give you bigger type. Also, all the screens are adjusted for color blindness, so making sure that the grayscale images of those colors are discernible, so people who are colorblind can still use the app. And now we come to the point of data. So Move is using a lot of sources of data to create this infrastructure of transit and mobility data. Of course, GTFS, GBFS, interfaces to Uber, Lyft, every taxis, and so on and so forth. Now, we use official data as the baseline for most transit data, especially in the US, but all over the world, very few, percentage-wise, very few agencies actually publish GTFS, and even fewer publish any real-time data, specifically in GTFS format. So we have a team of a few dozen people whose job is basically to curate and manage the data. So we ingest about 8,000 feeds today, turn them into metro-level mobility databases. So if you have like 6 agencies in a place that each one has their own GTFS, they all have different names for the same station sometimes. A very, very complex situation. Basically, we unify everything into a single database repository per metro. And in that metro, we do trip planning that is basically unified, validated, and curated. Now, in many cases, we take data from PDFs on the web. So there is no, all over the world, GTFS is almost, I wouldn't say scarce, but it's a few tens of % of our data. The last area that we're using is crowdsourcing. We have about 800,000 people, volunteers, that are actually helping us build and curate data. This is specifically happening outside of the US because the US has GTFS and GTFS real-time. But if you get out to Brazil, where there are like in Rio, there are dozens of agencies that they don't have any data. It's private operators that are running on lines, almost like without any official support. Private operators that run taxi lines. And we need this data because people use them heavily. And so we have volunteers who actually map that data and bring it to us. We then combine it into our database. Another item that we're using on that front is we're curating the data and we're working with machine learning. We have a lot of movement data. We have a lot of data on statistical data that we collect that allows us to correct schedules. So for instance, if a public schedule can say, okay, the bus stops here at 10 and here at 10:20, and we see that it never happens. It's always 10:40 because of traffic or whatever. We fix it. So we actually create projections of time based on actual statistical data, time of day, rush hour, not rush hour. Things can change based on reality, and we actually see the reality and adjust the trip planning accordingly. So we take all this data and combine it into a unified infrastructure. And as I said, it starts with GTFS, enriched by what we find out from statistical analysis, real time. We also incorporate service alerts. Service alerts are basically text announcements published by agencies. Let's say a stop is off this in the evening for maintenance or something like that, or a route is not operating. This is usually not translated into the GTFS because GTFS is a static entity, and this could be like a 2-day event. So what they do, they publish a service alert, say, okay, those stations are not operating this time. We actually take it and put it into the database. So we have machine learning algorithms that read Twitter feeds, agencies, websites to get those alerts. And we both show them to the users, but also incorporate them into trip planning. So when you plan a trip, you don't fall into a stop that is not working today. So how does it relate to accessibility? So actually, static GTFS and GTFS RT have provisions to provide information about accessibility. For instance, elevators in stops, in stations. So you could have a station marked as accessible, but the elevator could be broken. How do you know that? Theoretically, GTFS RT can publish this data. Not working today. I mean, it's not regulated. I mean, the government doesn't force agencies to publish it, so it gets lower priority. And the reality is it's a huge mess. Same thing about vehicle accessibility. More and more agencies, the whole fleet is accessible. But if you have a fractional accessibility, usually if a bus is down, they put another bus in. You don't know if it is accessible or not. And nobody tells you that, and there's no way to know it. So it's a huge mess still. We're mapping the stops very well through the community. So for instance, we have pathways within, if you have like a subway station or any station that goes from one place to another, we map the time it takes to get from one platform to the other and the path. But this is happening locally in specific stations, not outside. So if you're outside and there is an elevator, but it's not working or something, there's no way to deal with it for us. So we do expose as much as we can from the static data, from GTFS. Service alerts are also, they could publish elevator is not functioning on this station, and then we will put it out there into the trip plan. But again, this is more of a textual data, and it's not going to be used as accessibility information. So I would say that we're doing our best based on the data that we're getting and our community, but it's not real time, and it's not perfect or far from perfect. And as I said, we work with metro-specific areas with agencies to solve problems that they see and want to solve in the way they want to solve it, and we do that. Just to summarize, so again, 30% of our users have disabilities. It's a high focus area for MoveIt. The solution is not just data, it's data and how do we take this data and present it and make it usable. Those are two distinct areas, both very, very important. And the lack of data, which is partly solved with crowdsourcing and special engagement, is not yet there. And I think this is a big project for the hopefully near future. Thank you. That's.
If you don't mind staying up, because we'll call you up after John finishes his, and if John Campbell can join us up here now. We're going to turn this into a panel discussion after John's discussion. So John Campbell is Associate Manager for Transit and Mobility Software at IBI Group. John works with Arcadis IBI Group based in Portland, Oregon. He works on open source software tools for trip planning and transit data management. This includes Open Trip Planner, OTP, which is an open source multimodal trip planning platform that has been used by transit agencies around the world. He has worked with agencies including TriMet in Portland, ATL in Atlanta, Sound Transit in Seattle, and all of these to implement and enhance the OTP platform. John and his colleagues are currently working to augment OTP's trip discovery and planning features with booking and payment integration, which we talked about before, to form an open source mobility as a service toolkit. Throughout this work, John is motivated to ensure that technology, software, and data can help foster equitable and accessible mobility options for all. Thank you.
That was perfect timing while I dug through and found my slides. So thanks for the introduction. So, there we go. So I'm going to be talking about some examples of the data wrangling that we have to do to get data cleaned up and ready to support the trip planning features within OpenTripPlanner, using a couple examples of projects that we've worked on around the country and a couple here in the Puget Sound region. So first, a little bit about OpenTripPlanner. OTP is an open source multimodal trip planning platform. So open source just means it's software code that no one organization owns. Our Cadus IBI group is only one of many companies and organizations around the world that contribute to that software project. And it consists of a kit of parts. So there's the routing engine that actually generates the trip plans. There's an accounts and personalization module so people can set their mobility and accessibility preferences so that the trips get planned in a way that works for them. And then apps, including a web app and native mobile apps. So depending on the agency or the city implementing OTP, they have that kind of full kit of parts to build a trip planning tool that works best for them. And we do all this relying on open standards, open data, and APIs for all the input data that feeds into that tool. This includes a lot of what was talked about in the last presentation, so GTFS, GTFS real-time, GBFS for things like bike share and e-scooters, and forming the underlying base of that all is OpenStreetMap for our road, bike, and pedestrian networks. So now I'm going to talk about 3 different projects implementing OpenTripPlanner and some of the challenges we faced and lessons learned working with messy data from a lot of sources. So first up, right here in the Puget Sound area, working with HopeLink to implement a HopeLink and Cambridge Systematics to implement a one-call, one-click platform. And the OTP routing engine forms the back end of that system. And the routing engine supports both fixed route transit, deviated fixed, dial ride, and other types of flexible transit service. Some of the challenges that we faced working on this project is it's a routing engine incorporating over 25 different GTFS feeds for the region, including both fixed route service and flex service. Each of those feeds is produced by a different agency or organization, has a different update cycle, and all of that happening while the GTFS flex specification continues to evolve. So a couple of the things that we did with this implementation to handle these issues: in the back end of the system, we have automated monitoring, fetching, and validation of those GTFS feeds so that we can do quality checks, both for just validity, does it meet the specification, and best practices, are we actually giving good information to users. We also provide additional tools for creating and maintaining GTFS flex data. So if agencies aren't able to produce it themselves from an existing system, they can use our tools and produce their flex data that way. And then also we're a member and active contributor to mobility data, which is responsible for managing the evolution of these data standards. So we can provide the perspective on what actually works well for those implementations. Moving on to another Puget Sound example. Currently, we're working with Sound Transit on their digital assistant suite of tools. This will include a web app, native mobile apps, an AI-powered chatbot, and an interactive voice record system so that users can get all of their trip planning and arrival and departure information consistently, regardless of how they're accessing that information. As part of this effort, we've been updating all of the OTP apps, both web and mobile, for web accessibility, so meeting the WCAG standard. and then also adding localization and multiple language support. So even though these were features that were driven by one agency, because OTP is an open source tool, it's available to the full community of OTP developers and implementers to benefit from that work. So a couple of the challenges we faced on this effort for sound transit. The Puget Sound region fare structure has a lot of agencies, a lot of different types of fare classes, and that full fare system and structure can't really be modeled in GTFS data based on the current state of the specification. So to address that, we've been working with a number of other community members on developing the GTFS Fares v2 standard, and in the meantime, we've developed a custom fare calculator that's future compatible with GTFS Fares v2 whenever that gets kind of fully implemented and accepted as part of the main standard, so that users can see their fare information now, but it will also be compatible with that data standard in the future. In addition, multiple agencies in the region will serve a same shared stop, but they'll represent that stop totally differently in their GTFS data itself. So the stop names might be different, the stop codes might be different, and this can cause a lot of confusion if customers are seeing one stop name or stop code in the trip planning app, and then when they actually get out onto the street, they're seeing a different stop number on the sign or a different stop name on the bus when they're taking that trip. So to handle that, we've been developing a regional shared stops index that provides the data structure for agencies in the Puget Sound region to collaborate and coordinate on what their shared stops are currently flagged as in their GTFS, and then hopefully evolve their data upstream in the GTFS production process so they don't have to have that translation layer in the future. And then finally, as part of the web accessibility work, a lot of the accessibility standards can't be caught in automated testing. So just running through those automated tests isn't enough to ensure that apps are accessible for folks using screen readers and other web accessibility devices. So as part of this effort, we're doing a lot of manual accessibility audits, user testing with folks experienced using those types of assistive technologies, and then doing work to remediate any issues in the apps. And then last example here is working on the Georgia Mobility and Accessibility Planner. This is another ITS for US project, working with GDOT and the Atlanta Regional Commission in the Atlanta area. And this is building upon OpenTrip to really provide door-to-door support throughout your trip process. So from the pre-trip phase where you're seeing all your trip options, figuring out which itinerary works well for you, giving you updates and turn-by-turn directions to get from your door to the transit service, support at the transition point when you're at the transit stop and getting on a vehicle, giving you updates along the way when you're on the transit vehicle, such as notifications of when to get off the vehicle or if you're likely to miss a transfer and that kind of thing. And then providing a handoff between that outdoor navigation system to an indoor navigation system if that's something that's equipped at your destination. So as part of that, we'll be building out the ability to define mobility profiles. So users can define what exactly accessibility means to them, and working towards kind of a customized routing and in-trip support experience based on that mobility profile. So this project is still pretty early in the development phase, but already some of the challenges we've been facing. Many existing apps and the data standards that we're working with currently define mobility and accessibility with one-size-fits-all definitions. It seems like that's been a pretty common theme so far today, addressing that issue. And then a lot of the data to support these use cases, like customized accessibility routing, is still incomplete, unvalidated, and the environment's just changing faster than the data can keep up. So a lot of times on projects like this, you will see a long list of features that an agency would want to build, but then there isn't necessarily support to get the data cleaned up and ready to go to actually support those features in the long term. So our approach to addressing some of these issues, like I mentioned on the last slide, we're developing these advanced user profiles that users can define their own mobility, accessibility, and assistance needs and preferences to inform their planning and in-trip support, and enhancing the OpenTrip Planner routing engine so that when we're giving them their trip itineraries and in-trip support profiles, that's based on their mobility profile. And then finally, just working with members of the community at events like this and some of the data standard governance to ensure that the data being produced and the standards governing that data supports the features that we're trying to build in platforms like OTP. Thanks.
Thank you, John. Don't leave us just yet. We have questions for okay. Let's see. So I'm going to get a chance to pick up where I left off. And so when we last chatted before lunch, if anyone remembers, we talked about open sidewalks and how really at the core, our goal is to find a way to create a standardized, expansive sidewalk data network that can integrate with existing transportation networks so that we can provide routing and other kinds of analytics to downstream consumers. Let's roll back. We also talked about the fact that we can't just create a data spec in a vacuum. We're really talking about creating an ecosystem that allows people to both contribute to that ecosystem and then share back. Because the use cases are varied and they're important, and each use case exposes different issues with both data confidence and data quality. And so what we've really focused on, because we came from actually the consumption side, that's where we started our work, and then discovered that there was no consistent standardized data. Our approach really has been use case driven, where, as I mentioned, the generalizable data specification is really about creating the underlying network, and then the local regional specificity can also address use case specificity, which is important. So when we're talking about how we add things to OpenStreetMap in this case, it's really about adding an additional transportation layer, essentially, to that infrastructure. But what does that mean to downstream consumers, and how can they consume this at scale and for various use cases? And so our current open data projects are actually trying to address those needs at scale for multiple different stakeholders, because that gives us a purview on both, what are the heterogeneous accessibility needs by the end users who are using trip planners, wayfinding, and navigation aids. But we're also finding that institutions, agencies need to have this information in order to address questions like, what's my active transportation network like? They don't have that information. How do I prioritize or create a prioritization schema to address accessibility issues in a way that really addresses bottlenecks in the infrastructure, not just like, okay, we have 300,000 curbs that are not ramped, where do I start? So all these kinds of questions really all point back to that network. So when we're thinking about the downstream consumption, and as I said, we started out with accessmap.io, which answers the original question of how do I get from X to Y in a non-motorized mode, giving a specific mobility limitation. The next question was, how do we create walksheds around these areas so that we know what the size of the walkshed is for someone who requires curb ramps versus somebody who doesn't? What does the walkshed look like for somebody who requires controlled intersections by traffic lights as opposed to simple yield or stop signs? And so the walksheds and sidewalk score do the same thing of consuming the data, but look at it from a different perspective, in the sense that we want to understand connectivity from or to this location for a particular pedestrian with a specific profile, as John had indicated before. So the kinds of questions we're able to ask of those tools are, how do we identify streets that fail to meet certain standards? How do we measure street performance? How do we, at the user level? And how do we identify accessibility islands or access bottlenecks? So starting from accessmap.io, which is a web application, but now there are 2 mobile apps for Android and iOS as well. The mobility profile we're looking at there is an individual who may have mobility limitations, wants to be able to express their very specific needs about uphill and downhill inclines, their very specific needs about raised curbs, and also in the case of Seattle, as I mentioned before, because our participatory design processes told us that people really used indoor infrastructure to get around because there was no other way, we also allow them to specify what time of day they'll be traveling, because then we can say, oh, okay, the public library will be open at that time. You're able to travel through there. Now, when we look at the question that Uli raised, it's not just a data input question into these apps, but what do you show people and how do you display these variable information points about what is and is not accessible to them, when what's accessible to them is not necessarily homogeneously accessible or inaccessible to someone. So we developed a certain way of visually identifying that kind of information. So the app will dynamically change what's shown in the map based on what the individuals indicate in their mobility profile, so that if somebody moves the slider right or left, the visual output will be different. It's also important to say that people don't necessarily know their personal preferences when it comes to uphill and downhill mobility. And so we've also worked on creating tools to allow them to kind of train themselves in terms of identifying environments that they're familiar with and asking them, is this, this hill that you take, is this something that's typical for you? Is it hard for you? And that way they're able to ratchet in their preferences. Now, in our last discussion with Google in 2018, Google was not happy about that because, that defies the ethos of like a simple one-line search, right? That's not the same mode of operation. But these are perhaps not the same populations that are necessarily looking for that simple one-question line, but rather would be willing to invest the time in training themselves as to what their personal preferences might be and what their personal profile might be. And, I found it pretty instructive to know that, my personal preference is 10.3% grade on good days and a little bit less on other days. So I think, this is a little bit exploratory, certainly, and maybe not for the entire population at scale, but certainly addresses those questions, allowing people to hone in on what is right for them. And so what's also important, and we talked about the generalization towards the future, but we also want to generalize towards different populations. The same data in Open Sidewalks, which allows for flexible routing engines, can also address other unique challenges faced by other pedestrians. And in this case, we tried pedestrians with visual impairment. And so we have a custom pedestrian routing for people who identify as blind and visually impaired. And what we looked at there are the levels of controls at crossings. So is there a yield sign? Is there a stop sign? Is there a traffic light? And people are allowed to indicate for us, like, what is their overall preference in terms of getting there? Will they accept anything below a traffic light? Or are they totally inflexible when it comes to controls over the intersection? Likewise, we also marked landmarks and every manhole, light pole, bench, other markings that would allow for tactile identification and orientation to the path. Of course, this is a lot of data collection, so we didn't do this. We did this for the entire Redmond Microsoft campus because that's who funded this work. But it did give us an idea of how long it might take to do a full collection in a particular area, and that was really instructive for us. And so the output is a pedestrian route. We actually displayed an access map in the same kind of visual modality that I showed you before, but we're still asking the question of how to display these routes to people who are BVI, because I can't display the same visual screen to somebody who is blind or visually impaired. And so that is an ongoing area of work for us, and we're jointly working with XR Navigation, who produces Audium, on that question. Other things we can ask the same data, right? So accessibility isochrones. Can we ask how long might it take somebody to get in the area when certain features of the environment are available versus when not? So this is actually work that was done with Steve Lewis, who is here today with us. And we explored what happens when those indoor building elevators close down. What does the walkshed for somebody who is dropped off at Pioneer Square look like when they are dropped off during weekends and nights on the left without the access to building elevators versus what happens when the buildings are open? And you can see the visual difference. And I think earlier Karen, who left, talked to us about using the data for advocacy purposes. This exactly is what we're talking about. Being able to visually show this to Seattle DOT meant that they were able to say, oh, maybe we should work with building owners to make greater allowances for people to enter the buildings in off-time hours. Next is really an analytics of how can people access schools, parks, recreation facilities, health facilities, and other opportunities in the environment. So what we're seeing here is what is the difference in terms of just the number of schools and parks accessible to a person who has a normative walking profile, the general walking person in those digital apps versus a manual wheelchair user, which again, we're kind of prototyping here, but we're trying to demonstrate the point that in absence of curb ramps, there is a significant difference for how many of these opportunities for parks and schools people might be able to access. And lastly, we're really question of how can we allow departments of transportation and others to address the question of, well, what does the equity of accessibility look like in a particular location? And that's where the work on sidewalk score really ends up pointing to, which is to say, if I'm looking at, say, starting from a particular location, which is what's displayed on this as a purple dot, and given no specific restrictions around the distance of travel that's 400 feet, what is the walkshed around this area for somebody who has a particular, in this case, we're sort of characterizing a powered wheelchair user. And what does that look like against the backdrop of where a car might be able to reach in the same travel distance of 400 meters? So you see that there are certain areas that are cut off to that person using powered wheelchair mode versus the car. And so that tells you that the network is not necessarily equitable when it comes to those sidewalks present in that location. And looking further, starting from a different location, but also further restriction for a minimum width of 2 meters, you can see that the network is even more restricted there. And of course, we're looking at this for COVID purposes. The idea of demonstrating this is that using the data that is, again, detailed, objective, and specifies the full network allows departments of transportation to make an analysis on the spot. Like nobody knew 4 years ago when we collected this data that 2 meters width of the sidewalk was relevant, but we had that information and were able to do this analysis when COVID started and we were concerned about social distancing. Furthermore, as you look at these walksheds, you're able to see the vast difference in how different users might be able to reach in the same areas. And that gives us actual quantitative analyses about the equity score of those areas when it comes to sidewalk scores. So our current work is basically how can our data spec be both consistent, how can we create scalable and interactive use cases, how do we make our data spec self-sustaining, how do we account for a diversity of personal needs, and that's kind of the topic that was thematic here, and how to model a pedestrian because we're so diverse and heterogeneous among ourselves. So with that, I want to open these questions, and I see that the bottom of this slide dropped off, and sorry about that. I kind of want to run this as a design charrette, if you guys will join us back in the front. All right, so at this point, first, has anybody here either used Move It app, the IVI OTP instances, which are actually not in Seattle presently? Community transit. Or Access Map, so that they've experienced some of the personalized mobility profiles. Okay, cool. Okay, that's pretty good. That's exciting. So what I wanted to ask first is, what is a good discourse for, as users, to indicate what is your personal mobility profile? And so, for us as data consumers, that might mean it's feasible or not feasible, but just what is the conversation there that you might have with your digital mobile app that is relevant and potentially thorny? Anyone? Mark Hollenbeck.
As always, Mark will talk. Okay, to take the Google simplicity Can I split the difference between Google's simplicity of application to our degree of personalization? If it was me, the first thing I would want to say, because I like clarity, right, is do I need, and I had a word, and being an old man, I just forgot it. Do I need particular characteristics, or pick a better wording of that, for my trip? Just to say the good things for Google, right? When I do a transit, when I use transit, I want to go from here to here. The first thing I do is I say here to here, and it gives me something. And the next thing I say is, yeah, but I need to arrive at 4:15, right? And the arrive at 4:15 is a secondary button. So what I would like from you is an indicator that I want a secondary button. Because as soon as I say, I want special characteristics in my route, then you can open up that more complicated user interface, because I've already said, I want a complicated user interface. I want to say, I'm a traffic guy, no toll roads, right? Or I want to say, please, I can't climb Cherry today. I just can't do it, right? So no, I really want this. And so to me, that's a nice, quick introduction. And then the last thing I would say is, because it's a web application, phone or otherwise, save this, right? And then I can always go back and say, yeah, I want to change it today, but I know that that's the case. So to me, that's the level of simplicity that I would look for as a user. I want a quick one that says, I'm unusual. I like to think I'm normal, but I've come to the conclusion that I'm not very normal. So I want I'm different. I want something for me today, and then I'm volunteering to do the extra levels of details and then save it, because just like my passwords and user stuff, my web browser remembers that on this website, this is my user ID and I just have to type my password. So to me, that's the step between the complexity that I want and the simplicity of I'm just going to use it, I'm going to use it, I'm going to use it. So that's my suggestion. That's how I would approach the conundrum of I want that extra complexity, but I also want simplicity. That's the choice. Anybody else want to have a better idea?
Thanks, Mark. Well, no, I mean, it's not a better idea, but I just, so with HopeLink for the One Call, One Click project, and I have so many questions on the writer profile aspect of it because we hosted a 2-day workshop that some of you were able to attend around writer profiles and just seeing all the discrepancies and we're not asking the same questions. But Mark, to your point, I think what we've learned in the process, and it's all still in theory because we haven't started user testing, is how you build a profile over time, right? So how do you ask the right questions? And we do this in mobility management. You ask only the questions that they need in order to figure out your best trip options. And then it's when you have a more complicated trip that more questions are asked and then how that ends up being. So I am curious maybe to ask a question from what Mark said of like, how do you learn over time, be able to ask just the right questions? What are the most important questions you have to ask first? And then what are the more complex questions? And maybe you don't have it in your app right now, but maybe your wish list too of what you would like to be asking.
Okay, so we have all those. I mean, so our basic default screen is point A, point B. How do I get there? And then you start getting into, if you have conditions like arrive by or schedule for tomorrow, or all those kind of things are secondary, deeper level options that you have access to, but if you don't do anything, point A, point B, nothing. In terms of profile, we do have a user profile that, for instance, if you need wheelchair access, I mean, then usually if it's permanent, you want to save it. So you don't want people to go in and every time say, don't include micromobility in my trip plans, right? So we have a profile, but again, it's not mandatory. We don't interview you as you log in or sign up. Hey, tell us like in half an hour set of questions. You start adding those as you find trips that, they bother you. Say, I don't want this. You go in and you change it. I think one more thing is learning with time. So for instance, we know you take line 5 every day, 20 times in the past months, and that's your commute stuff. So we learn that, and we start adjusting our trip suggestions and also notifications to address the frequently used routes or trips or things like that. So clearly, consumers don't have patience, and we understand it. Let's take it one more thing that I want to say is about people with disabilities, paratransit, and all those kind of guys, eligibility situations where people has to be whitelisted for something, they need to put it in, right? So if you're a student, if you are, a senior, so for ticketing, for ordering special services, those require you to fill out your specific profile stuff.
Do you want to say?
Do you want to go next?
I could, okay. So I have several responses to both of you, actually. First, I do think we have to hierarchicalize the questions. But even once you get to the secondary, what's important to you on secondary may not be the same thing. And our list is now hundreds long. So there is an aspect of really, in some cases, creating these white label apps that are specific to a subpopulation, because at least we know that what's secondary to your subpopulation is specific that way. And that's why Access Map VI is a different app than Access Map that's addressing mobility concerns. The other thing I was going to say is that through time and actually tracking some of what our contributors' data has shown, is we're looking to see how they interact post-route. So they requested a route and they specified their uphill and downhill mobility limitations and curb ramp, requirements and things like that. And now they're trying to negotiate with the application because they're unhappy with what they got, because given the infrastructure, we just sent them all around Seattle to get around Queen Anne. So that negotiation piece is really important for us, because it's really instructive for us to know that, hey, they're actually willing to give up some comfort. Like maybe they'll jump a curb or two. Steve has told us he'll jump many curves in the past, but there are other users who may not. And so that kind of negotiation piece is not singly about profile, because in the profile, they still prefer to have curb ramps. But there are opportunities for that discourse. And that's a little bit more fuzzy because it's not a user profile per se, but it's super important because the infrastructure is not there to allow them to, the less direct route may really be like several miles longer. So that has to happen in the app itself. And I think the last piece is really about what you had asked before, which is how are we knowing that these data points actually make an impact? Like if somebody's using the app and they moved from using it on a desktop to a mobile application, we know they might be trusting the data more because there's more of that spontaneity in travel that they might be using. Like, oh, I'm downtown and maybe I'll hop over and have coffee with a friend, which was not previously planned. So they'll plan the trip, in a mobile situation. Whereas previously, as I showed, like there's 2 hours of planning at home with all those different visualization tools to address mobility concerns. So I don't know if this answered all of the questions. I think a lot of it is very much exploratory because we don't have, these mobile apps at scale currently working for everybody, but I think we'll get there. So we certainly have the tools to analyze the data that's coming back from our users and being able to tune these apps on an ongoing basis to them.
Cool. So OpenTripPlanner's mobility profiles are definitely less mature. We're still kind of in the design, building them out phase. So I can't speak as much to what we currently do, but more what we're thinking about. And one of the big challenges that I think has come up in all of our presentations is how do we translate someone's subjective impression of a part of a trip? Like, I think of Cherry as steep. I don't think of Cherry as 14 degrees. Into that quantitative thing that a trip planner needs to be able to route successfully. And so I think that's where having like little intercept surveys or questions that come up either during a person's trip or after a person's trip can help us understand from what their profile originally was set to be, making little tweaks to kind of dial it into what their actual preferences are.
One more. So one more thing that I think is a good hint is that, there are phone settings that are not for the app, generic phone settings that are accessible to the apps, and we're using it as well. So if you are, if you need larger fonts, we read it from the phone. Language, we read from the phone. So we're using as much information as we can that is available for us to tune without bothering the user with asking them what the profile is. So I think it's an important point because there is information there.
Talk about in your sidewalk application is there are good curb ramps and bad curb ramps, and downtown there's a particularly bad collection of curb ramps in some places, especially the International District, and that could really get into route planning, and it's something that I suspect sidewalk application doesn't have the ability to really take into account.
So quality in general of curb ramps, of sidewalks. So this is where the interaction with the OpenStreetMap community was actually really consequential, I should say. OpenStreetMap is really clear about only mapping infrastructure detail that is there. And so the consideration of the quality of a surface was at the time, or at least it's still largely, there's no standard for describing a gap or a gash. You can say, oh, the remaining width in this path is 2 feet, and then we can tell the user whether or not their wheelchair will fit there. But in the case of curb ramps, I think you're absolutely right in that curb ramps, as Karen mentioned, things were built over time, things are not maintained, and so it's really hard for us to offer an objective measure of how bad is this curb ramp. especially when it comes to having volunteers be able to contribute that information. But I think, just like we're able to provide like temporarily constrained sidewalk information, we're also able to provide that information. I think we just need to identify a way to put it into the spec that is acceptably standardized across the board. One of my biggest concerns is doing something like a lot of other crowdsourcing is doing, which is empowering just general users to make accessibility determinations about a curb ramp, and without a certain level of training, you might just get wildly inaccurate data. And so are we better off giving people poor impressions of the general population about accessibility, or just not addressing it at all? And I think the last point I'll make is that poor data is sometimes worse than no data. From Seattle, we were getting for a long time these feeds of permits of where sidewalk closures are. And of course, those permits are inaccurate. Sometimes people lie in their permits about how much impact they will have on the sidewalks. Sometimes they didn't intend to have an impact on the sidewalk, but it's actually there. A lot of the times the permit temporal limitations are inaccurate. They'll give the permit for a month, but the work is only 2 days long. So we were trying to take in these feeds, like Uli is saying, but there was no way of inferring when the actual impact is on the sidewalks. So we took that down, because better to be uninformative than poorly informed in our perspective. And maybe the crowd has a different opinion about that.
Yeah. If you generalize the situation is can you crowdsource this kind of data? So clearly having somebody going and testing every one of those, it's prohibitively expensive to do, right? And maintaining it. But if every user, their phone, again, in Move It, we're using for users who allow us to do that. We actually track what's going on, and this way we can adjust schedules, we can adjust what's going on based on actual user, I would say behavior, but not only behavior and the effects, what's going on there. And I think that, and we have also people who are editors, volunteering editors, they have actually access to say, hey, this stop is not in the right place. It's 50 yards to the left. Now, one person says that, we don't change anything. But if we see that somebody says it, and then we do a clustering on where people are standing in this area, and we see that they stand 50 yards to the right, then we have enough information to actually correct that. So if there is a permission situation right now because of privacy, that if people would volunteer to give their data for this project, you can create a lot of sensors that are automatically collecting data and then creating much better solutions.
Yeah, that's actually one of the things we're working on in OpenTrip So if a user wants that kind of in-trip support where they're getting notifications about when to get off the bus, we have to at least temporarily collect their data, but can use that to understand whether they took the trip as planned, whether they deviated from it, and potentially that could update their mobility profile or get notifications of disruptions or anything like that.
So we have like a reporting feature of cleanliness of the bus, right? Somebody can say this bus is dirty. And we collect this information in real time and we send it back to the agency. They can decide, okay, this bus is to go somewhere. Somebody vomited there or something. And there's no other way than user reports on that. So if somebody who's trying to tackle a ramp and says it's broken, right? I can't go up that. If you can report it, it would be an amazing, I think, asset to this program.
Yeah, so that's where I think the onus, so you guys don't necessarily openly share your data, which is fine. But on us, we're using OSM. It's really on us to contribute that information back when we can. I mean, if the feedback we're getting is not up to the community's standard in terms of, this is transient information, but they don't want it, that's different. The hurdle has been that, in OSM, identifiers are ephemeral, they're not necessarily persistent. So it's been really hard for us to do that synchronicity back to give back the data. And I know that that's being addressed in the community as well, but I think that's a really important part of closing the loop, absolutely. And you can say what.
Hi, thanks to all three of you. I'm Taylor Reich from ITDP. So, Uli, you talked a lot about sort of these temporary things that can happen, service alerts, or a bus being dirty. These are clearly a big problem in public transport, and it seems like you've got a great strategy for handling them. But they're also a problem in sidewalks, right? And in other modes of travel as well. Someone might have parked their car on the sidewalk, causing a temporary obstruction, or maybe there's a big dumpster there or something. So, Anat, have you been thinking about ways of handling these kinds of temporary obstructions?
Yeah, so that's what happens not on the data spec side for us. It happens on the consumption app. So Open Sidewalks addresses that by Access Map addresses that by placing temporal boundaries on when is this pathway available. So it might be always, but it might be temporarily unavailable. In some cases, we've actually created one white label of the app that allows people to just say, I don't like this path, like for whatever reason. They don't even need to tell us why. And that removes it from their own network on the edge device. So that is our way of handling it, just to put constraints on when that path is usable, and also sort of numerical constraints in terms of what is the effort or cost to this person to use this particular pathway. And that means that when we do the routing analysis, it just ends up being, thrown out because it will drive the cost of this route to infinity, basically.
So I guess a follow-up question, when we're crowdsourcing obstructions, how do we confirm when that disruption has been removed? Yeah, it was like someone parks blocking the sidewalk. We have 5 or 6 people who flag that in the app. So then we start routing people around out of their way. Do we prompt people with push notifications in an app to say, hey, is that car still parked there? Or
yeah, Waze, right? So Waze, and I'm a Waze user, and every time I'm going with it, hey, is the police car still there? Is a car stopped there? So I'm constantly being asked what's going on. So clearly there is a technological problem of how do you know what's going on? Even when the obstruction occurred, first person reports it. Is it true? Maybe it's just, he's just lying. So how many do you need to say that it's real, right? So very, very tough situation. You need a lot of data in order to really support it. So I can tell you ideas. Again, this is more like for university stuff. Today cars are becoming with cameras, right? So one of the things that we explored, didn't do it because of density, but to find where there are open street parking spots using Mobileye autonomous vehicle traveling around, finding those spots. As it drives, it looks for, it finds potholes, it finds parking places, it finds a lot of stuff that's going on, can report it, and we could actually consolidate it into a service, right? So there is a lot of technology now. Cars are connected, lots of cameras are around. There are possibilities to do these things in a more automated way, and I think that's the future, if anything.
Yeah, I will say that this is kind of connected to our conversation with MV Transit and King County Metro Access. We don't quite have as much Internet of Things on the sidewalks. And for sidewalks, the pedestrian view is actually really important. You can't quite get this information from the perspective of a Google Street View car or something like that. There are lots of occlusions that we can't get around. But in trying these kinds of applications, like the thought around using access vehicles to have those high hanging cameras to be able to do this for sidewalks is definitely an ongoing conversation that I think we now have the computer vision to do this. We just need the right application that would allow us to drive around at scale, and do that continuously, right? To be able to feed back and maintain the data on an ongoing basis, like I was talking about before. If you don't have this feedback mechanism, the data is just dead on arrival, and we spent all this time and effort for the time being, but not further downstream.
So this is totally hypothetical, wild idea, but if those delivery drone robots that companies are piloting become more of a thing and scale up, maybe a city requires that as part of their permit, they have to have sensors on the drones that then contribute sidewalk conditions back to some kind of data structure. Maybe open sidewalks.
So, yeah, we've talked to Washington state legislators. When they allow the sidewalk robots to operate in their cities, like, come on, people, we're essentially allowing our public utility space to be commercialized, and we are getting no data in return. And so the least we can do is ask those companies for that imagery back. Or, if you're able to do the analysis of there's a sidewalk here and here's how it's connected, or the temporary barriers, that would at least give us that mechanism for maintenance. Thomas?
This is a really interesting conversation, and I'm intrigued by kind of one of the disparities I see in this conversation, which is, Yuli, you're talking about some frankly very advanced features in Move It, as well as in ways that you mentioned as a user. And we're talking about Open Trip Planner and Access Map not having some of these like notification and automation features. And it strikes me that there's a disparity in resources there in a couple of ways, in terms of these public projects not having been able to set up all these complex modes of operation, not having the funding to do that. Move It being able to institute those automations, not just because of money, but also because of unified business processes that allow an organized company to deploy the staff members to do that. And your point, Anat, I think is really important. It seems to me that one of the gaps there is public policy that ensures that certain types of communications are some that don't get stuck in certain silos of business processes and proprietary ecosystems. So I'm curious if you have, any of you, from any angle, suggestions on public policy, that might encourage broader and more equitable adoption of those advanced features.
So I think one of the issues that all these types of apps, when in transit data is involved, run into is a lot of agencies produce GTFS and it's out there. It is what it is. Quality's inconsistent. And so apps like, whether it's OTP or Move It, we end up needing to do a lot of data cleanup to get that data usable for end users. It was encouraging to see that now transit agencies that receive federal funding have to publish an open GTFS feed, but requirements around data quality and accuracy for both static and real-time data could really help things.
Yeah, I think I look at micromobility, scooters. Scooters is a very interesting problem because it's a mobility solution that runs on public ways, not on the pavement, on the roads, but on the sidewalks in many places. And you can see the evolution of public policy. First of all, right now, there is a public policy. Almost every city that deploys scooters, they require the scooter company to report everything, basically location of all the routes, of all the locations, charging routes. And they also deploy policies on which side of the street you can take the scooter off, where can you park, and if you don't park or you don't enforce it, the scooter companies are penalized for that. So public, and that's because of the issues that the safety issues of scooters and the control that the city has on its sidewalk. I think on transit it's different because it's much more convoluted, and because the usual transit system goes through many municipalities, so it's very hard to unify something. But as a municipality by municipality, I think that relatively easily can enforce licensing technology deployment and receive data back. I think that's something that I see happening.
Yeah, I think what's important is to raise the idea among legislators that sidewalks are utilities just like the electrical system and the waterways. And so they wouldn't just allow commercial access to those utilities without a lot of regulation and a lot of principles behind it and a lot of identification of the cost benefits to the population. And I think, because we've demoted the pedestrian spaces for so long, that's just not been the case. But, I think there's a lot more of an understanding for it now, particularly in Washington State, where we just adopted complete streets policies, because we have to elevate the regard for the pedestrian spaces to better understand safety and active transportation and use of public transit, et cetera. So it's getting there, but we just need to really push it onto legislators so that they have a full understanding of how that transaction should take place.
Hi, I keep thinking about two things in this discussion, and one is weather, and another one is the amount of work needed to properly maintain a mobility device. So, for instance, an intersection of those two things might be like there's an atmospheric river coming through Seattle. That never happens, right? And then I'm in downtown Seattle, and I'm going up or down Madison Street that is paved with bricks. We also know that maybe some of the infrastructure might be compromised because the drains next to the sidewalk are flooding, and then the curb ramps are full of standing water. And I should not drive through that if I want to keep my wheelchair in healthy condition. So I'm wondering to what degree we are making assumptions about the weather conditions that we're trying to navigate, and to what degree can users assess their risk with respect to maintaining their mobility.
Thank you for that question. Do you want to address it, or? Okay.
So the one thing that I can say that the service alert service, again, I'm talking now about public transit. I'm not talking about sidewalk but if there is a flood in a street, right, and there is a way for anybody, right, to put a feed out there that says this street is flooded. They know. When there is a power outage today, you go to the website of the power company, at least where I live, and they tell you, yeah, from this block to this block there is a power outage. So there is a feed that tells you about those kind of things. So weather in general, I think it's much more complicated. But in terms of local issues, like a pothole or those kind of things, they should be reported at least as a feed, and then assigned to a street, and that should be relatively easy. I don't think it's happening. I mean, but this is a mechanism that could work.
So from this is just our standpoint, and also again back to that interaction with OpenStreetMap, we made a decision early on to really abide by the community practices of only describing what features are there, but then AccessMap as the consumption app joins in external data. So essentially what we'd be doing is when we're mapping the sidewalk, we'll just say, what kind of infiltration is here? Is there good drainage? And people might indicate yes or no. Then when AccessMap has this information, they'll join it with today's weather and say, oh, there've been 14 inches of snow so far, probably not a good time to use this pathway. Right, so that will impact the cost of using that path. And specifically, we've done this in places where, as I noted, the local community is both identifying this as an area of concern, and also willing to collect that kind of information, because it's a lot of detail, right? So we have to get local community buy-in to say, yeah, we really care about this aspect of the roadway or the pedestrian way in order to collect that kind of information.
All right. I'm going to ask a question which might put us on a different tangent. So ignore the question if we have no answers. So all the things that we've been describing about writer profiles and how do we tune these results in order to get a pathway that a person really needs. We all start out from that position of able-bodied person, and then we impose this workload upon people with different abilities to navigate these applications and input their personal abilities, and that's a big another just burden we put on people who have different abilities. If you had $1 billion and like unlimited time, like what would you look into in order so that these applications that we're dealing with have that information already from the person without them having to navigate these kind of hurdles in order to find the trip that they want?
So my first thought is this seems like something that, not to use a buzzword, but machine learning could really help us, because if someone's using an app, taking a trip that they know they're comfortable taking, we can get the data on what that trip entailed, and then build up a pattern over time and see kind of in the background without a user answering a questionnaire what their kind of revealed preferences are instead of their stated preferences through a survey.
Yeah, first of all, I think if you ask 10 people, they will give you different answers. I mean, so there are different people have different preferences. So it's real. It's not like there is one way that we can fix it. You have to adjust because there are many flavors. Just to give you ideas about not only disabilities, it could be I want the least carbon emitting route, or I want the cheapest one, or I want the fastest one. So you can have multiple reasons, and depending on the time of day, your need, and they change. So I think that you can't avoid having some kind of a control function, give a control function to the users to adjust what they need for that trip. And I agree, learning what they usually do is a good practice, and I think we're trying to do it. But again, it's not 100% because you need a lot of data to do that.
And I think also, like, we've been talking a lot about routing as a single thing, but really when you're routing for a trip, there's kind of multiple phases of that, right? There's like trip discovery where you just want to see what your range of options are. There's trip planning where you're about to actually take that trip. You need to figure out which of those options you're going to take. And then there's kind of the on-the-fly routing or in-trip support where you're in the middle of that trip and you need updates or a reroute or something. And at each of those phases in that overall routing workflow or process, your preferences could be totally different. Like during the discovery phase, you probably want to route based on your like average or typical preferences. And then when you get to the actual planning phase where you're committing to a trip, that's where more of these on the fly, like today I care about just getting there really fast. I don't care if it's a more expensive trip or it's raining, so I'm gonna take a different route. So having like those different points at which users can give their preferences and update them seems like an important part.
I don't have much to add to that. I think it's that kind of negotiation after the fact is really still going to be important, irrespective of the starting point. I'm sorry to cut off questions. We're actually 10 minutes behind. I want to allow the next panel to come on. So allow me to thank our panelists. Thank you so much. Thank you.